All right, here we are in part two of this two-part series explaining how you find the uh, the location of an image behind a mirror using ray diagrams. So we're going to take this the first step at this point after having this incident ray and reflected ray drawn. I'm going to actually call this incident ray A and reflected ray A, because we're going to have to do another one, but we'll get to that. So what we need to do now is take our reflected ray, right? So if we were, I just realized something. I drew this perspective incorrectly. So I'm going to redraw that. All right, so we're going to leave that one there. That's one possible perspective, but we're going to just draw in another perspective down here. All right, so this is the viewing perspective. So for the rest of, let's just say this is like the perspective of like where the light is coming from. So let's call this the origin perspective. That's not a thing you need to know about. Origin of light ray perspective. And then we're going to use this perspective to talk about the image right down here. So the viewing perspective. This is the perspective that actually matters for understanding how this works. So we're going to be viewing from here. And then, so we're going to imagine, like, if we're over here looking at the image, the reflected image of this thing, right, we would be down here, and we'd see this light ray that bounces off the mirror from that thing. And what we would appear to see is this object behind the mirror, right? Because there is a mirror here. So the light ray that bounces off looks like it came from over here. So what we're going to do is we're going to extend this reflected ray backwards. I'm going to darken in the actual reflected ray here just a bit so it's darker. And then we're going to go with I'm going to try to make it a little lighter, the extended ray backwards. So this is a virtual light ray. There's no light actually passing through this that is related to any of this over here, because of course the light bounces off the mirror, right? It bounces off the mirror and continues on. So the light rays are all over here. But if we're looking at the situation from this viewing perspective, then it looks like the light ray came from behind the mirror. So we would see an image back here somewhere along this line. Where exactly on that line? Well, we need to draw more rays to figure that out. So here we go. This is going to get a little bit messy, but that's okay. Actually, I'm going to do these light rays as long dotted lines, okay, to just try to help differentiate things a bit. So I'm drawing one more incident ray to the mirror. All right. One more incident ray. Good, just like that. Now I need a normal line for that incident ray. I'm going to go ahead and do it this direction. There's the 90 degrees. I'm not being quite as precise as I could be, so this might end up being a bit off in the end. But that's okay. All right, there is our 90-degree normal line. And then we need to figure out, actually what we need to figure out, we need to use this normal line, figure out what the angle of that incident ray is. It looks like it's pretty much right at 30 degrees, just a tiny bit less than 30 degrees. So 29 is what we'll call it. So we're going to flip this around. And actually, let me just verify that. Yeah, 29 degrees. So we're going to flip it around and get it all lined up. And then we need a 29-degree angle coming away from here. So this is 10, 20, this would be 30, so we're going to go just a little bit below that, right about there, and draw the reflected ray. Okay, so like this. Off, just a little bit off there. All right, so this is our incident ray B. I'm just going to call it incident B. And this is our reflected B. All right, so the incident ray B is coming in this way, and the reflected ray is coming out this way. And again, we're still viewing from over here. So then what we're going to do is take our second reflected ray, our reflected ray B, and we're going to do the same thing. We're going to trace this one backwards as well. And we'll notice that we get an intersection point between reflected ray A extended backwards and reflected ray B extended backwards, right here, that spot. So actually, I'm not going to draw it like that. Just this spot right here is the that's where the two lines meet up with each other, right? If we extend them backwards. And that should be the location of the tip of the image of this object. So we could then, at that point, redraw the object, which looks like it is, let's just go ahead and make it an even size here. 15 millimeters tall, I think. Yep. So then we come over here. 15 millimeters tall, right? So we draw this little trunk, draw this, Christmas tree shape. And there you go. That's where the image of our object should be. So the object is here. The image on the other side of the mirror would appear to be, right? The image appears to be here at this location. So this is where the image location is. It would be appearing in this spot right here. And we can figure that out with these ray diagrams that we drew. I don't think it's quite the right size, but you should get the idea at this point of how it works. Now, just a quick check. Did we do it correctly? You can check the distance, right? The distance of this object from the mirror is actually 130 millimeters or 13 centimeters. And then if we go to here, the distance from the mirror to this object, it's I've got it here at 131 or 132. So here, I'll show you. You can see there it's just a little bit more than 130 from the mirror's surface. And then we go back over to here, so we've got this there. And you can see it's 130. So if we do this properly, we should see that the location of our image behind the mirror is the same distance behind the mirror as the object is in front of the mirror, that it's a straight line across, right? It's like perpendicular to the mirror's surface from where the object is. Basically, it's the same size and the same distance from the mirror as the object is. But the whole point of this activity was to show you how to use ray diagrams in order to find this. Okay, so it's very important. This is what's called a ray diagram. We've drawn very carefully using a protractor these incident rays and reflected rays based on where the mirror is. And this is an important skill for you to be able to use. So there is a full demonstration of how that works. Hope that helps you to understand things better. And that's it for this video. Take care.